Okay, picking up where we left off, we're on page 273 talking about phone stuff. The last one they talk about is this thing called WiMAX. WiMAX was a pretty cool idea at the time. I think it kind of it was overcome by the other cellular technologies, and this really isn't available anywhere today. One of the purveyors of this was a company called Clearwire, and they had one of the service areas that was, nationwide was actually here in our area, and we kind of checked it out and looked at it, and it was pretty cool. But they kind of, I don't know, they just didn't keep up, and no one adopted them, and so they're just kind of a footnote to history now. They're not really around. And again, wireless comes up with new things all the time. Jeez. Hopefully they'll come up with real terms. I wish their G was directly applicable to some sort of speed. It should be fairly obvious that the amount of growth in data is absolutely enormous. That these companies, particularly the wireless companies, have to just continually upgrade, and continuously move things along. And we're not necessarily talking about more cell phone towers. We're talking about changing the technology in the cell phone towers and then increasing the bandwidth between cell phone towers and the rest of the networking system. They're talking about DVDs and quality videos being watched on phones, and that takes an awful lot of bandwidth to be able to do that. So this is just kind of a little footnote, basically saying, yeah, if you're in that business, then you're constantly chasing additional things. Okay, the next thing that we're going to talk about is the actual physical wiring of a network, the so-called topology, because you have some choices when you're putting your network together. So let's just get into the networking topology. The first one is called a star network, and a star network looks like this little diagram here. This is what most people have in their businesses, and this is what I have at my house, for example. In the center of this star, I have a router, and I use the term router, but it's lots of things. So my router has like 4 or 5 functions. 1, it is a router. Cool. 2, it is a switch, which means I can have like 5 things plugged into it. It is a wireless access point. And then it's a firewall. So it's a router, a switch, access point for wireless, and it's a firewall. It does lots of things. Anyway, that's the guy in the center of this. And so coming off of that is a couple of hardwired machines I have, and I got a wireless printer and a bunch of wireless phones and stuff, tablets and that kind of junk. So it's all connected. Now, what they don't show in this diagram is coming off of my wireless router, I go to my cable modem. So typically it'd be like a wire coming off that hooks up to the rest of the networking. The rest of the network is the internet in my case. But this is what it looks like in most corporate America. They have like probably in the geographic center of a floor, like you have a building, and smack dab in the middle of the floor, they're going to have cables run like in the ceiling, going down to these drops in each one of these little places. And they put, of course, in the center because the cable links are kind of important. In this world, most likely they're going to be using just standard Ethernet cable, and the range is about 100 meters. So they put it in the middle rather than one of the ends. Okay, this is an old style network. I don't see this anywhere that I know of now. But it used to be what you did is you ran one giant coax cable like in the ceiling, and then you would tap the cable. You would tap it and then drop a line down and hook up to your computer. So the problem with this is if the main cable broke, the main cable that ran the length of the building, if that guy broke, nobody could talk. Here, if this one breaks, well, only that guy breaks, right? If this one over here breaks, only this guy goes away. But this guy, when the cable breaks, everyone goes down. So that's not good. Okay. And then the other one is called a mesh network. And mesh networks are almost always designed for a wireless, although you could do mesh with wired. But here's how it works. I have a laptop, And I'm not close enough to the wireless access point, but there's somebody that's halfway between me and the wireless access point, and he can get connection to the wireless access point. So he's got internet, but I don't. I'm a little too far away. But he shares his internet with me. So I'm leapfrogging. For me to get to the internet, I have to send to his machine. His machine says, hang on a second. And it forwards it on. Okay? That's how a mesh works. And it's designed so that it's kind of redundant. If this machine in the middle dies, well, it's okay. All the rest of them can still talk to the internet. Now, there's a really cool example I want to show you. If you've ever heard of the One Laptop Per Child program, this is a charitable organization that tries to get small laptop computers in the hands of impoverished people all over the world. That's what they do for a living. And this is what their little laptop looks like. And it has two little antennas. Now, two little Wi-Fi antennas. Why would you think they need two antennas? Maybe because it was designed for a mesh network where it could be transmitting on one and receiving on the other simultaneously. Ooh, right? Okay, so this guy actually has essentially two Wi-Fi cards inside the laptop. And it's designed so that, let's say that you're in an impoverished area somewhere, and maybe the local school has an internet connection, but none of the houses in the area have internet. But the school does. So all the kids turn on all their computers sitting at their home, and the kid that has the house closest to the school can pick up that wireless signal. Then he rebroadcasts it into another little area. And so this guy over here picks it up and he rebroadcasts it. And this guy over here picks up and he rebroadcasts it. So what you're doing is you're essentially setting up repeater stations for that one internet service. So it's very likely that you could have one internet connection at a school and that signal be repeated like 50 times so that it eventually fills the entire neighborhood. So everyone in the neighborhood has access to the internet. Pretty doggone cool thing. It's called mesh computing. Okay, let's continue. Well, mesh network rather. And it is pretty doggone cool. As long as, let's say this is the guy who's closest to the internet. If that guy goes down, okay, yeah, everyone goes down. But everyone else, these guys can be fairly fault tolerant. The system is really designed so that, single point failures typically don't occur. Pretty cool stuff. Okay, let's continue. The next thing we're going to talk about is these networking types. And so they make some distinctions for what's called a personal area network, a PAN. Okay, these are guys where, you either have like a cable or you have a very short range wireless scenario like Bluetooth, those kind of guys, right? This is a wireless connection. It's really designed for like one person. I mean, Bluetooth, you have to kind of pair your device with whatever, right? And so it really wasn't designed to be sharing that. I mean, in other words, although physically you could, I could have a hands-free set for me, a hands-free set for my wife, and we could both be using the same phone, okay? Not simultaneously, but, all right? So, but it's really designed for one person and very short range. That's all there is to know about PAN. Short range and one person. Local area network, okay, well, that's normal. This is the, what you probably heard these terms, 10 base T. That's the name of a standard. And there's 100 base T, and there's 1,000 base T, and there's, which is also, sometimes people just abbreviate it, gig-E, gigabit per second Ethernet, gig-E cable. Okay, lots of goofy terms. Anyway, there's a table there that basically goes through it. The limiting factor on these guys typically is like 100 meters. That's the length of a cable for a local area network. Now you can piggyback it. I mean, I can have a switch, 100 meters, another switch, 100 meters, another switch. I mean, you can have lots of these guys so that you can extend, by repeating itself over and over again, you can get a lot further than just 100 meters. The next thing to talk about is the metropolitan area network, the MAN. Stick it to the man. No, not that. Okay, this is slightly different. This is like I have like a college campus or a military installation, and I want to connect a building over here to another building over here. And so you're probably not going to be running twisted pair cable that distance because it's just too far. Remember we had that 100-meter limit? 100 meter works great from inside a building because I can just repeat the 100 over and over and over, and you, most likely every building, except maybe like the Pentagon where you have a huge building, but most every building the interior wiring can just be a local area network. But when I want to connect two buildings that are a couple miles apart, I got to have another option. So a metropolitan area network is how those things are done. And I'm not going to go into too much detail, but basically telling you it's a technique for connecting like two LANs. I have a LAN inside this building and a LAN inside this building, and I use a MAN to connect the two together. A lot of people go third party with this. Let's say, for example, I have a Burger King franchise on this part of town, another Burger King franchise on another part of town, and I want to be able to have, send messages back and forth. I'm probably not going to hire somebody to string wires on the pole. Okay? Right? First of all, they're not my poles. They belong probably to the phone company or the utility company. So I just contract with a third party saying, hey, can you connect the two together? And they go, sure, no problem. And remember we talked about packet switching? So the route that they take may not be the physically shortest route between the two, because maybe they'll go around and around because it doesn't really matter, right? Okay, cool. Wide area networks are talking about huge geographic areas. So now we're talking about connecting, Killeen to Waco. So now we're not talking about a couple miles, we're talking about 100 miles. And so once again, the techniques involve a slightly different. And this should match the discussion about the types of networks where you had near and medium and far, right? Okay. So this is the satellite kind of thing, right? Okay, cool. So that's what that's all about. Let's continue. The next thing we're going to talk about is kind of a philosophical view of why you should employ networking. Now, to me, it'd be fairly obvious why I want to do networking is I want to be able to get to the internet and I want to be able to do email and all the rest of that. But let's talk about some of the philosophies behind this. Okay. In the old days, you had centralized processing, which means you probably had some sort of a mainframe computer or a mini computer, one of those kind of cool terms you've heard. Probably in a closet someplace or a computer room or in the basement that no one could get to. It was glassed off and locked up. And everyone had dumb terminals. And so they had cables coming out, go into a series of dumb terminals, and your terminal didn't have hardly any processing power at all, if any. It could be just quite literally a keyboard and a screen and nothing else. Okay. And this worked pretty good. And then they started talking about decentralizing. Decentralizing means, maybe I should have put a computer over here and have another computer over here and they will just talk to each other. Rather than having one giant computer and a bunch of dumb terminals, we'll just have everyone gets a computer. And this worked pretty cool. And this is where we've been for quite some time now, obviously. We've decentralized. And so I have processing devices that are all over. Distributed is kind of like a combination of the two. It's sort of like where parts of it are centralized. Because, for example, I still have to have like my email and my database in a central location. But other than that, everyone else can have their own little copies of Microsoft Excel and Word and stuff on their own computers. They're not running off some server someplace. Okay. They talk about, in the old days, file and print services and email were probably one of the first uses of networking stuff. Long before Microsoft got into the game, they were networks before that. And we all had email and we all had places to share files and way we can send print jobs to remote printers. That existed long before Microsoft got in the game. Okay, this is a good place to stop for the 15-minute mark. We'll pick this thing up in just a few.